What's up guys, Shawnthebro here, and today we're going to be going over multi-input commands, or whatever we end up calling them, part 2. So basically, what we talked about in part 1, episode 99, was that we sometimes need to be able to perform an action by pressing 2 inputs at the same time. Meaning, like, in this case, let's say to perform a throw, I need to press my light and my heavy attack. So to do that, I press them both, technically within a specified number of frames, but also I need to never release either of the 2 inputs. If I release the input, even if I press them one after the other, then we don't want the command to fire. I need to make sure they're both being held at the same time to perform it. And anyway, we got that working in part 1. But we did do somewhat of a hack because the logic we had prior kind of stopped us from doing it. And actually, it wasn't really our logic that stopped us from doing it. It's really Unreal's input action logic. It's not to say Unreal is to blame. I just was not aware of that when we initially set it up, that 2 inputs from the same input action cannot be pressed at the same time, or rather they can, but Unreal will only pick up the first one that was pressed. So instead, we're changing the logic up a little bit. We're removing the hacky logic that we had in the past, and then we are going to implement the new correct method to do this while keeping everything else we've done working. And so with all that said, let's get started. So, to catch you up, this is episode 100 of the fighting game tutorial series. It's true, 100 episodes so far, and plenty more to come. If you'd like to catch up on the entire playlist and all the episodes we've done, or if you want to look through the episode list, I'll leave the playlist right here in the top right corner. Otherwise, I'll leave a link right here in this icon in the top right corner to part 1, which was the previous episode, if you are just interested in performing multiple inputs at the same time to perform a command, specifically with use of the input buffer. Because this could be done a lot easier if we didn't have to incorporate it into our input buffer and make it work with all these other rules that fighting games have. But if that's what you're looking for, then that's the episode for you. So let's go to our fighter template character.h, actually, in this case. And let's look at what we've added for today's episode. So if I scroll down, I always love to show you what I've added. There's a few things we're going to need to take care of today. So we're going to change our input action system up a little bit. And so using the input buffer to this point, what we were doing was having this one input action called, I believe, press any key P1, press any key P2, or something similar to that. So if I actually go and look at this, I'll show you what I'm talking about. Yes, the add to input buffer P1 and add to input buffer P2. Now, this was basically allowing player 1 and player 2 in keyboard mode. For those that aren't aware, multiple players on one device, such as a keyboard, is a little bit more complicated, so I've added a separate input action to handle that in the past. However, for example, say I want to press 2 of these inputs at the same time, like L and K. It might be I and K, but either way, say I want to press them at the same time. Let's say I want to press I and K at the same time. Now, if I do that, sure, I can press them both on my keyboard or my device, of course, at the same time. The game's not going to reach out and stop me from doing that. However, it's not going to actually trigger for both of these input actions. Whatever one gets pressed first, or if they're on the same frame, whatever one it reads first will be pressed, will be performed. And so with that said, it's going to do whatever one is received first and ignore the other. Now, it can, of course, accept multiple input actions on the same frame. So if I press, for example, G and W, they can both be done on the same frame. It's just one input action cannot be pressed at all if the input for it is already being pressed. So no matter how many frames I wait, if I press L and I hold it and hold it, and then I press K, it's never going to register those 2. It's only going to register the first one that was pressed and held, which is L. And so in the last episode, we fixed it with a minor hack. What we're going to be doing is actually fixing this and basically just making it so every input that we have is going to actually add it regularly and independently without going through that input action system. So we're going to keep everything with our input buffer the same, don't worry, but we're going to do a few extra things to make sure that we call it from the right places and we use the right input action. We're going to create our custom event. Okay, so with that in mind, what we need to do is capture presses and releases for basically every key in the game. I'm going to cover things like jump separately, but you could do it now if you'd like. I just don't even have any commands that require jump outside of actual air attacks, which aren't really the same in this case, so it's not going to affect us here. But just know, we will cover that kind of separately. So, for all my input actions that are mapped in, if I go to Fighter Template Character CPP, and I look at my Setup Player Input Component function, I have all these actions mapped. And I actually had these, believe it or not, but I had them commented out, and I believe I called them like Stop Attack 1 or something. The name doesn't matter. What we're going to do is we're going to actually capture all of these inputs when they're released as well. And so to do such a thing, I need functions for that. So I've created, as I have one for each attack button that I have, I also am going to have one for each release attack button. So for example, if G is my light attack and I press G, it's going to trigger start attack 1. When I release it, we're going to trigger release attack 1. You can do this for every attack you have. We have 4 attack types. And so you say I have start attack 1, release attack 1, start attack 2, release attack 2, 3, and 4. As you can tell how this works, it takes the input action in. You guys have probably seen this before if you've been following the series, but basically it'll take the input action name that we set up in the project settings in Unreal, attack 1 P1, see if it's pressed or released, and then it'll call this function when that occurs. So when we press G, we call start attack. When we release G, we call release attack. Okay, once you've made these, we're going to have to make another function in our fighter template character.h. And this one I'm going to call, if I could find it, perform input logic. So I've made this a blueprint implementable event, U function, which means we call it in code, but the logic is done in the blueprint. So what this really does, this is going to be our new event. In the past, we were using this. I didn't delete it, I just disconnected it. We were using this input buffer logic P1 and P2. We were calling the input action, or rather, we were capturing the input action and doing different things on pressed and released. If you're familiar with the series up to this point, you'll know what this is. So this stuff is good. You know, it works except for, it worked up until now. And now we're running into some issues with it. So what we need to do is create our own custom event that can fire whenever and isn't determined by when an input action is pressed. And then we can do the logic that we expect. So disconnect, add to input buffer P1, and add to input buffer P2, both pressed and released. You can leave everything else here connected and in your logic if you want, or you can flat out delete it. I'd recommend keeping it at least until you make sure that this other method is working for you and everything is good to go. You won't have this yet, of course. We're going to add it in here, but that's what this event is going to be. So that's why it's a blueprint implementable event, because we're going to do the same thing that we were doing in there in the same blueprint, just using this new event. It's going to take in the type of input that it was and the status that it was. So G for light attack and press when we pressed it, or G light attack and release. We do have a few new variables as well. In fact, we really only have one new variable, and I'm going to rename another variable, so that makes a little bit more sense. You haven't seen this used yet, but I'll show you where it's used in a few seconds. Oh, really a few minutes. If we scroll down, we had a Boolean in the past for directional inputs that was called has released input, has released axis input. And I've renamed it now to be has released right axis input. And I've created another variable, pretty much set up the exact same way, but called it has released left axis input. What these are what we used it for initially was if the input action was pressed, or excuse me, an input axis was pressed. Now, an input axis is something that has a scale. It determines how much you actually have pressed an input or how far. So, for example, if I want a controller and I have my analog stick, I can press it, 10% of the way, halfway, or all the way to the, whatever direction, left, right, up, down, diagonals, whatever. And we can actually capture that. So when you look in your project settings, you'll see that there are axis inputs. Just like there are input actions and action mappings, there are also axis mappings. And so specifically in this case, there are others that we could do, but move right P1 and move right P2 are the ones we care about. They have scales. Okay? So for those, what we were doing in the past is basically we didn't want to spam our input stack. And you can see I put the category as input stack. The input stack on the screen, if we play in practice mode where we can see the input stack, the input stack was spamming left or right because input axes are always running. If I hold left, it would be spamming left on the input stack on the left side of the screen. Like I said, they're always running because they're always tracking whatever the value is. So even if the value is 0, it has to know that. That means the analog stick is not being pressed, but it has to be called to do that. And we don't want that always printing that input stack. So we made that variable initially for that reason. Well, now we need to know if the left or right key was pressed or released, because we're going to be doing some fancy stuff with it to make our lives a little bit smoother. So for now, all we're going to use it for is, if you ever noticed, you can't really press left and right at the same time. This is only really on keyboard and devices where you have that ability. On a controller with an analog stick, you won't be able to do that. But if you're using the D-pad, you could, to an extent, try and press them both at the same time. And so if you're in that sort of situation where you're trying to press them both at the same time, you would never need this for actual gameplay reasons. However, it could screw you up as a player. Say you are kind of spamming buttons or you're trying to perform a command, you accidentally press both of them at the same time. Really what we want it to do is cancel the other action. Like if I press left and then I press right, instead of just standing still, we'll really want to cancel left and go right. We can't currently do all of that. However, we're basically going to set some groundwork to eventually make that work in the future. We're setting it today because what we're changing is kind of already related to that anyway, just with input actions, not input axes. I think it'll make more sense when we get into it, but just know that's what they're used for. This determines if the left and right axis inputs, so specifically, left and right on the analog stick or left and right on a keyboard, are pressed or currently released. I do have it as has released because of where we're using it. So I want to know, has this input been released? Because once it's set, we want to stop doing certain things. It's okay if that doesn't make sense for now, because I'm going to explain it in more depth when we use it. But just make sure you have 2 of these variables now. Let's go into our fighter template character.cpp, and let's go to our start attack and release attack functions. Now, start attack is something that you will have. Release attack, we made it in the .h just now, but we haven't set these up. So go ahead and set up these functions. Start attack 1, release attack 1. Basically a release attack for every start attack that you have. And we're going to change, well, really we're going to keep all the logic the same, but we are going to update where the logic for being added to the input buffer really is. Because normally all this would actually be done when any key was pressed by the press any key event that we had in the blueprint, remember? This add to input buffer event, really. But we don't want to do that anymore. We want to use this. So now what happens is whenever we press an input tied to the character, because we do want it to be an actual value that is mapped in the character, otherwise any key I press on the keyboard would work, and we don't care about that. So anytime I press any sort of input that does any sort of logic, anything that can work in the game, I need to make sure I add it to the input buffer. So to do this, I call our new fancy function, perform input logic, and I pass it the types that I want. Now, since this is a function and that's mapped to a specific type of input action or input axis, I know exactly what is being added. So in start attack 1 is when the light attack is pressed. So I want to add an E input type of light attack, and I want to add the status as press. Okay? Now, when we go to the release attack, I still want it to be, I know it's release attack 1, so I still want the type to be light attack, but the input status should be release. And now this will be tracked, and we'll know when we pressed or released that type of input, light attack in this case. All right. And you're just going to do that for every single attack that we have. So start attack 2 is medium and press. Release attack 2 is medium and release. 3, you can probably guess by now, heavy and press. Release 3 is heavy and release. Start 4 is special and press. Release 4 is special and release. And that's all for now. But make sure you add it for every attack type you have. We're going to do it for other things that we also care about that could either potentially be part of our input buffer, combos, special moves, anything like that. So the other cases I have are jump. So when we press jump, I have to add the E input type jump and make it a press. I don't actually do it for stop jumping, which is not really, there's no reason in particular that I don't, just we don't ever use release jump. We will use it when we get into like hops versus regular jumps, which is something we will be implementing. So you can feel free to add it in now if you want, but I'm going to have to cover that function entirely separately later on. Okay, other places I do care about it are for crouching, both starting and stopping. So in start crouching, we want to add the input type crouch with a press. For stop crouching, crouch with a release. Since we have manual and automatic blocking in our tutorial series, I have to cover that. So I do block with press for start manually blocking, and stop manual blocking is block with release. However, if you're using the automatic blocking where you block just by walking away from your opponent when a proximity box hits you, then you don't have to actually add anything here as there's nothing being added to the input buffer. So you can just leave the start automatically blocking empty for this and not add anything to the stop automatically blocking either. Now, that's pretty much all you need to do for all of our input actions. The tough one is the input axis. It's pretty confusing, so what I've actually done is broken it out and put it above the rest of our move right logic. And it's pretty big, but I've commented each of these, even though it's very simple, just so we stay on task with what we're doing. I've really expanded this, taken up as much room as I feel is necessary, and then the regular move right logic is below it. This could definitely be cleaned up and made nicer and neater, but I thought it was too much to change for this one big function that we have. I want to explain it first. We're not done with input buffer stuff. There's still things we can do, not necessarily to clean up our code, but to make it actually nicer to use for the character, or really for the player. So when the player's doing things, if you've ever seen like assist mode or easy inputs, it's not always that it's helping you. Sometimes it's like you have to do less inputs, or yet the timing is less strict. But there's also certain things where the movements, the inputs don't have to be as precise. So if it's like a quarter circle, maybe it only cares about if you press down and right, as opposed to missing that, as opposed to pressing that diagonal, that down right input. And so there's certain things like that that we'll do. So we'll be revisiting this and continuing to make it cleaner, in which case we will probably make this function a little bit neater. But for now, I thought it was, like I said, pretty complicated with all the changes we're doing. So I'm breaking this out entirely, and hopefully you'll understand what is going on. So the input axis is a little bit tougher because we still need to add press and release inputs for input axes. Like, we still want to know if the player pressed forward or backward and when they released it, because first of all, when we press it, it could be part of a command, and so we need to track that and add that to our input buffer. But we don't want it being added every single frame. Like I said, it's called every frame, and we don't want that to update. So we don't want to add like 100 lefts to our input buffer just because we held it for 100 frames. The way that input axes usually work is like, if it's a charge attack, sure, I want to be tracking that I'm holding it. However, if I perform an action, say it's a back light punch or something, I can't hold back on the initial like backward input and then press back and then press light attack. Usually what would happen would be you would have to press back, and then light. It does depend on the game, so I can't say for sure that you can't do that, but in this case, I'm accounting for you don't want to be able to do that. You can always update your logic to make it work that way. Not too complicated, but I'm going to show you how to make it so that it's as precise and as much as the standard fighting game input buffer as I am aware of. I think that's the most common method, and so I'm going with that for now. Okay. So that's why, it gets tricky for those reasons. That's why we have to know, like, if you released it and things like that. And the charge inputs don't make it any easier, so there's kind of a bit that we're doing here. All right, so here's my move right function. And I've just written this above everything. Like you can see, if you're looking at your move right function, it probably looks like this to start. You know, all this stuff, and then it goes into checking these. Let's just take some things. Let's just take away from this. Just go above it. Let's start fresh, and then I'll kind of explain how everything works together and how you could condense it if you want to do it on your own. So, we want to do some things that are, you know, we want to add inputs to our input stack and our input buffer, and we want to track if certain inputs are being pressed and whether we should cancel them or keep them, and there's a lot going on here. So the first thing I check is if the character is crouching or not. If they're not crouching specifically, meaning they're standing. And this is important because the move right inputs are different if you're crouching. If you're crouching and you try and move right, left or right, remember, move right encompasses left and right, and the value is either -1 for left or 1 for right, 0 if you're not moving at all. And so whether you're trying to move left or right, if you're crouching, then it's going to do a down back input or a down forward input. So it does make a difference, and it's actually going to have different logic as well. So I check and make sure that we are not crouching. If we're not crouching, we want to do the standing logic. So I've taken the liberty of updating the icons on the screen as well, because the input stack, as I discussed in the last episode, was kind of a bit broken. It would only add if we were able to perform the move and things like that, which is not really how input stacks work. They're supposed to track all your inputs. So I've updated it here in the input axis as well. It's not required that you do that, but I think it's cleaner and nicer. So essentially, if the character is standing, then I check the value that comes in the move right function. If it's greater than this value, 0.01, or really the dead zone on keyboard, then that means that the player has pressed right. Doesn't matter forward, backward yet. That gets determined, you know, in one of these branches later. But that means that the player has pressed the key bound to the 1.0 value on the device. So basically, they're trying to move to the right. That's what that means. So if this value is greater than this, then we know that the player is trying to move right, in which case we want to add input icon to screen. This is something we made during our input stack episodes. This is the index, which happens to be index 1 for the right key, or for the right image. And we were using, in the past, has released axis input, and that determined if we wanted to print this multiple times. In this case, we want to pass in has released right axis input. You're always going to pass in, from now on, the correct axis input for the direction that you're moving. So since this is right, we want to pass in has released right axis input. Because maybe we want to print the input stack for the other icon. Say we press left and then right. But we don't want to keep printing right if the user is just if they're just pressing the right key. That would span the input stack, and they wouldn't be able to tell what's going on whenever they were pressing an input axis. All right, like I said, I've broken this up more than it has to. So you can feel free to condense this, but this is the easiest way I could think to explain it. What we really need to do here is we need to make sure of a few things. So we need to know when a press happens, which is easy because we can check the value, but we also need to know when a release happens. Now, it's easy with input actions or action mappings because, first of all, you can flat out just do IE released in the setup player input component function, like you saw us do with release attack 1 through 4. But the problem with that is it doesn't tell you what key was released. It just means that that input action was released. So in the case of an input axis where we have a left and a right that are both bound to the one axis mapping, then whenever we release either input, you would see that the value is 0, assuming that the other one is not pressed. So say I pressed A, which is left in my game, and then I press D. Well, if I release D, I'm still going to have a value because A is still pressed. So you see how I could release a key and the value could not change? Alternatively, I could press A and I could release it and the value would go back to 0, but it wouldn't tell you what key was actually pressed and which one you actually released in that case. So what we're going to do is keep track of which inputs are pressed, left or right, and then perform logic in our input buffer according to that. You'll notice a pattern here as we go through it. So essentially, we can see that we're pressing right here. So if we're pressing right, we want to see if not has released left axis input, meaning if they have not released the left axis input, that means that the left axis input is being pressed right now. So I'm pressing right and left was already being pressed. That's what that will mean. If that's the case, I'm manually canceling it now. I'm saying has released left axis input is true. We have released it. So basically we're canceling out left. We're just performing right. Then what we need to do is add to our input logic that same logic, okay? Because before this was handled by the input axis released section here. This was done by the engine. But now we manually have to keep track of it. So all we do now, and we're going to do this for every single input in every single case, is we have to determine what direction the user is facing so we know what input that refers to. So in this case, we're releasing the left axis. So if they're going left and they're facing right, that's a backward input. So we want to call perform input logic, pass in backward, and release it. And my comments are actually wrong here. So let me fix that. Probably doesn't make it any easier. There we go. Copy, paste. Okay, so yeah, but if we're if we were pressing left and that's what got released, and we were not facing right, meaning we were facing left, then pressing left is going forward, and so we want to release forward. Now, after we've taken care of that, we want to look at what the direction is that we are currently pressing. We know we're pressing right, so now we check and see has released right axis input. And so what that means is if this input is not currently being pressed or held. If it's not, we know we want to add it to the input buffer. Remember I said we don't want to hold it and keep adding it to the input buffer? We can charge it and that's different. But when we press it, if it's a command that requires that input, we want to add it when it's pressed. And so we don't want to keep adding it. So if the right axis input has been released, or really if it's not pressed currently, then we want to say, okay, now it is being pressed. So we want to set this boolean to be false. We have not released the right axis input. And then we want to add this sort of binding to our input buffer. So assuming that we are pressing right and we are facing right, that is a forward input. That is a forward press. So we perform input logic with forward and press. Alternatively, if we're facing left, we're pressing right and facing left, that's backward. That's a backward press. And so we're going to manually add those to our input buffer. Now, let's look at the next case scenario, which is if we press left. So else if the value is less than negative 0.01. That means that the user is pressing a value that is less than the dead zone, and that means that we are going left. So in this case, it would be pressing A for me. We want to add the left arrow to the input stack using the left axis input. Okay, so we're going to do the same logic that we did above, which is where, remember, if you somehow are pressing both the left and the right at the same time, we're clearing this up. That's why we did this. We said, yep, we've released the right input. And so we have to put a release action to the input buffer. So if we're releasing right and we were facing right, well, that would have been a forward input. So we're releasing forward. And again, my comments seem to be incorrect, so my apologies there. Again, copy and paste. But alternatively, if we're not facing right, so we're facing left and we are releasing right, okay, so we were facing left and going right, then that is backward. So it's a backward and a release. Alternatively, the player is pressing left and we are not currently holding left. Then that means we want to say, yes, we are holding the left input and we want to add this to our input buffer just like above. So if we're trying to press left and we're facing right, then that would be backward for us. So that's a backward press. Otherwise, if we're trying to go left and we're facing left, that is a forward input, so that's a forward press. Else. This is an else to say either value is not greater than 0.01 or less than negative 0.01. Basically, it's within the dead zone, or really it's just not used at all. It's not being pressed at all. So if this is the case, I check both possibilities of if left or right was previously being held when this was released, and then I reset it and I add that to the input buffer. So I check if not has release left axis input, really meaning is this a input that the user is pressing or holding? And if so, we're going to manually trigger release. Yes, the user has released this. And then we're going to check the direction they were facing and add a release. So if they're facing right, and we were checking if they were pressing left. So if they're facing right, pressing left, then that is a backward input and it's a release. Wow, I really got a lot of these comments wrong. In fact, I might have gotten them all wrong. It's pretty impressive. Okay. Now, if they're pressing left and facing left, that is forward. So that's a forward release. Otherwise, if they were pressing right, we want to, again, manually say, yep, release right. And so if they're facing right and they're releasing right, that's forward release. If facing left and pressing right, then that's a backward release. So hopefully that makes sense. Basically, we take whatever input was pressed last, either right or left, and then we force it to be released as far as the game is concerned. And then we add the proper value to the input buffer to say, yep, we released this. Now, this else ties to the is crouching. Remember we were checking is not crouching right here? This else all the way here ties to that one. So else, if the character is crouching, I still do the same check for right and left, but we don't have to do nearly as much logic. Here for now, all I care about is adding the correct icon to the screen. So this would be down right. And then I want to make sure that the user is not already holding this. So if they have released it, great. That means that they're not currently pressing it. And we can now trigger that logic because it's the same thing. Whether you're crouching or not, you don't want it spamming the input stack and the input buffer. So nope, say, okay, this is the first time that this is the press that this is being called on. And so we determine the direction. If they're facing right and pressing right when they're crouched down, that's still a forward press. If they're pressing right and facing left, then that is a backward input and it's a press. Else, in this case, we are pressing left. We want to add the down left arrow to the input stack. Then we want to check and see if the left axis was being pressed. And if it wasn't, if it wasn't being pressed before, then we know this is the time we want to add these things to our input buffer. So we say, yes, this is being pressed now. Then if they're pressing left and facing right, that is backward. So it's a backward press. And once again, and lastly, if they are pressing left and facing left, that is a forward press. So I've tried to break this up as much as I can. You can definitely condense it, but it's about as clean as can be as far as expanding it and trying to point out every single thing with move right. So hopefully that makes sense. Okay. Now, once you're done all that, I left all the original logic in here for the move right function. So you should have all this. The only thing I've done is I've taken out the add input icon to screen function calls in all these areas because we don't want to double add them. And we don't really want to only add them under these conditions, which is why I move them out. You'll also have to change the names now because before we were only using has released axis input. But we need to make sure that we're resetting the proper values for each one. So if the character is moving right, we set has released right axis input equals false instead of just the old variable that we had. Otherwise, if the player is pressing left, then we say has released left axis input equals false. Okay, and then in the else, we were just saying has released axis input was true, but now we're resetting that here in this else for both right and left. So I've just commented this out. I'm going to take it out entirely from the else down below. You don't need them. And then I add movement input as regular. I change my names if we're crouching. Right axis input if we're moving right. Left axis input if we're moving left. And the else was setting it to true. We're taking that out now. All right, and that's what your move right function should look like if you're following this exactly. If that's the case, you can feel free to change the name from has released right axis input and has released left axis input if you want. I know it is a bit confusing. However, I named them that because A, we named it that in the episode where we added this variable. And it does technically make sense for what it is. Although it's a little bit confusing, it is the truth. It's basically, has this input been released? You could call it, has pressed and just flip the values. You could say is right pressed, is left pressed, is forward or back pressed, whatever you want to do. So feel free to rename it. But that's the way I think of it in my head. And we already have is pressing backward in these other sort of variables that are technically useful for other reasons. I don't want to necessarily toggle these on and off, false and true, all the time. So it'll make more sense when we get into more of this like accessibility and assist mode. And I'm going to have an entire episode dedicated to making the controls easier and smoother. And this will get cleaned up more, as I said. So don't worry. I know it's a little ugly now. I just really broke it out like that so I could explain it, because understanding is the main part here. We can then remove some of these other variables and kind of do what we need to do in a smaller section as opposed to having this huge move right function. Okay. Move right controller. You can feel free to make the same changes in it if you'd like. This is another topic that I have to cover. Specifically, just making controller movement smoother, because they are totally different. As similar as they are in the function right now, they are actually going to be totally different. Same logic, right? But different ways of smoothing it out and making it easy and fun to use for the player. So I'm keeping them separate for now. All I've done is I've made sure that I'm not getting errors. So I did update the names from has released axis input to has released right axis input on right, has released left axis input on left. And I technically set them both to true here, since that's what we were doing before. And then same for the crouch logic. But you don't have to mess with that now. I will go over that in depth when we go to update it in the future. Okay, so I know that was a little convoluted, but that's basically what we need to do. So now we need to see what logic we can put in that function that we keep calling perform input logic to make it work the way we need for our input buffer and our input stack to work correctly. Okay, before we get into the blueprint, it should be noted, I meant to mention it earlier, but you can remove the hacks that we put in last episode. So in Start Attack 1 and Start Attack 3 in my episode, or in my code, I had hacks where I was manually adding inputs to the input buffer. You can see I've removed them now. That was simply because we didn't have this system in place, but now that we do, you can remove them gladly. All right, and once you do that, you can load up the engine and go into your base character BP. Let's take a look at what we got. So like I said earlier, disconnect these input actions. Feel free to remove them if you'd like. This is what we're worried about right now. So this is actually a simpler function, and we can make it work for both player 1 and player 2 without even making two different actions. So it's just neater all the way around. Okay, and what we need to do is we need to determine what status was passed into it. So all these places we were manually passing them in. And here, I'll stick on one of these. Like here, I was doing backward release, right? Or we were doing forward press. So we need to determine if it was a press or a release. And we're going to do a switch on it. So to get this event, since we made it a blueprint implementable event, you just go to any child blueprint of the code class and type it in. So we want perform input logic, and you want the event, just like that. And then you can drag off of status and do switch, and it'll do a switch on that enum type. So we have press, release, hold, and none. None would be if nothing is being pressed. It's not important for this part because we're not going to manually add that here. We actually do that in the code already. Hold, as I mentioned in the previous episode, is for multi-input commands and actions, but we don't need to actually do anything with it here because we're handling it separately. We already handled that when we check for our commands. So we really only care about press and release. So they're going to follow pretty much the same logic. We're just going to do a few differences with each. We're going to pass in different things to the add to input buffer, the press, and the add to input buffer for the release. And then we're going to call different charge time functions as well, because that's also important. So I've made a new function called determine charge frames. In determine input data for buffer, we were calling this before for these add to input buffer P1 and P2 functions, but now our method is easier and we don't have to do everything in here. This was finding the key that the user pressed, finding it in the input map, and then adding it to the input buffer. Well, useful, sure, but we don't need to do that anymore because we're not using that event and we're not grabbing the key. We're passing in the actual type of input that it was, like light attack, forward, backward, that sort of thing. But there is something we need, and we need the charge attack functionality. So if you have charge attacks in your game, you'll notice that in determine input data buffer in the charge attack episode, I added this bit of logic, which made me add a local variable to the function called charge frame count. And then I looped through our charge times, made sure that the input that we're checking now is the input that we're looping through. If they are equal, I update the charge frame count, the local variable, and then I return that amount. Well, really, I pass that amount into the input info charge frames in the add input to input buffer function. Basically, all I'm saying in that is I'm grabbing the amount of frames that this input has been charged and adding it with the input when it gets passed into the input buffer. I was already doing that. This is not new. So what you can do now is copy this whole section. Really, you only need these nodes right here. Copy that, make a new function. I made a new one called determine charge frames, and I pasted it in here. Once you paste it, it should look like this. You should have all that in there. And we're going to return the charge frame count. This is just so we can use it more easily. We don't have to copy this logic and put it in two places in the event graph. Instead, I can just call it because we do need it on press and on release. So in your function, to make everything work, when you copy it over, you won't have an input type in the equals here, obviously, and this local variable won't exist. So to fix both of those issues, you can scroll down on the left where it says My Blueprint, open up local variables and add a local variable, call it charge frame count. This is the number of frames that this input has been charged. Now pass that in to this function, set it equal to the charge frames off this break, just like we were doing in determine input data for buffer. And before we were calling add to input buffer right in here, but we don't want to do that because we have other information in the event graph that we're going to use, such as the type here. And so what I've done instead is added a return variable on this function. So if you click on the function itself, you can see there's an input parameter and an output parameter. You can add them by clicking the pluses. The input parameter is going to be our enum input type. So literally add a new parameter, look for input type, and this is going to be our input type, or basically our key or controller button that we're pressing and what type it binds to. So if, remember, G is light attack. Well, then this is going to be light attack that gets passed in. Now, the output parameter is what we're going to use elsewhere. So we're going to use the frame count that we retrieve from this function elsewhere. So I have an output of frame count, and I made an integer 64 because that's what frames are tracked as by default. Now, once you add this, it'll add a return node for you. But if for some reason it doesn't, I have seen that as a bug, or if you delete it, you can always type in add a return node and add it here. And then just use your local variable that's down here and pass it into frame count. Only do this on completed. Don't do this on loop body, otherwise you will overwrite your charge frame count in this loop if done incorrectly. Okay. And so now determine charge frames will look like this. You have to make sure that you pass it the input type that we get from this event. So you can see the reroute nodes that go down here. You can see how they're all connected. They go into the input type on this function. And then it has an output of frame count. Well, we want to use that for our add input to input buffer. So the way I've gotten it to look like this is I call add input to input buffer. And you may be familiar because we've done this before in the series. It has an f input info structure, and we split it. Then we can fill in whatever we want. For the status, you could, figure it out by passing in the status. You could also just hard code it. It doesn't really matter. I actually chose to hard code it here because I think it's easier to read. I know this is a press, and I know this is a release. There's no confusion about it. For the input type, you're going to pass in just the input type from the event again. The input info frame is actually the current frame. Remember, we don't really use it outside of debugging reasons, but it knows that's basically what frame this was actually added. So you can just do get frame count, and pass that in. And then for the input info charge frames, that's your return value from determine charge frames. There you go. And then you're going to do the same thing for release. You can see I have frame count, and release is the input status. This is the type still. Then, like we were doing before, this is no different, just a little bit simpler yet again. We're doing start tracking time or start tracking charge time and reset charge time. So we need to do both of those here. So once again, I call start tracking charge time and start and reset charge time. So if I grab these, they look like this. They have input to track, charge input structure. You split them, and you get it to look like that. And then all I do is I pass in the type once more that we got from the event, so we know what input it is. And then these other two actually don't really matter because they're going to be set inside of the code. And again, you'll be familiar with this if you're familiar with the series, so there's nothing to worry about. But just in case you're curious, right in here, it's going to set these variables accordingly when needed. So at that point, you're actually good to go with this event. This should track all the presses, releases, and technically holds correctly. And now you won't need those other events, the add to input buffer P1 and P2. And you don't need 2 for player 1 and player 2. This is done in the base character. So anytime either character calls those, it's going to call it on that instance, which will know if it's player 1 or player 2. Then in your character that you want to add commands to, just make sure everything is still correct. Like I've made sure that my charge attacks still work, my multi-input attacks, they should still work without the hack. So that's what we're going to check right now. All your inputs should still work. So we're going to go through it really quickly together. Make sure that everything still works the way it should. So we load into the game. I can still crouch. I can still jump. I can still directional jump. Actually, let me load up practice mode even, because that will be useful for checking the input stack now. So I can crouch, I can jump, I can left, right. You can see if I press like right while I can't move, it still gets added to the input stack, which is what we want, and that did not work before, so now it does. You also have your directional inputs working nice, even if you don't press them at the same time. That's very convenient. Additional fix there. Okay, so we have our basic attack that works. We should have directional attacks that work, and we do. Okay, and then we have, let's see, we have commands, so like fireball. Okay, and then we should have a charged attack, which we do. And to verify that that is working as intended, we don't want to be able to use the charge attack if we just press that input without actually charging it, and we can't. Okay. Lastly, we should be able to do multi-input commands. So if I press, in my case, it's Z and G are the buttons I have to press. Okay, so if I press them separate, even if I press them quickly and close together, nothing happens. If I press them together without releasing one within a few number of frames, you can see that I can actually perform my command and throw. You can see it actually goes the other way as well. Again, we didn't actually cover priority order. I wanted to cover it today, but I did not. I'll cover it in one of the next episodes. There's actually a little bit more we have to do with priority that I didn't initially consider. It could be useful. And now back in versus mode. So now that you can see everything is working, you should be able to do all your attacks, and everything should work golden. The only issue you may have is, like I said in the last episode, if you press both inputs at the same time, literally, well, not literally the same time, but literally on the same frame they get picked up, then you'll see that your character won't do anything. And this is because we don't have a way to track multiple inputs on the same frame. I was initially going to add it to this episode, but honestly, it needs kind of an episode to itself, and this episode's already running long. So let's put that off to another episode. But just know that everything should work unless you press two inputs on the same frame. At this point, the input buffer is feeling pretty solid. We need to clean up our controls, specifically the input axes and the move right. Clean up that function and the way it actually feels. But other than that, I think we're in a pretty good spot with our input buffer, and we can do pretty much everything that we need to be able to do. So it's time to get into combat flow. I started combat flow, and I was waiting to kind of get our input buffer set up so that we could mix and group everything together, because it's going to be important for us to be able to do everything we need so that we know that the system is working as we go and move through it. Anyway, guys, that's all I got for you, so thank you so much for watching. If you enjoyed, please subscribe. It does more for myself and the community and the channel than anything else you can do. I really appreciate it. I want to give a huge shout out to my Patreon members and YouTube membership subscribers. Thank you guys so much for the love and the continued support. I really appreciate it. It helps me more than you know, and I'm so glad that you guys are interested in seeing this game and these tutorials as much as I am interested in pumping them out. So thank you so much for 100 episodes, everyone. Here's to 100 more. Lastly, guys, if you had any issues, feel free to reach out to me on Discord. Join the Discord community in the link below in the description, and I'll be happy to assist. Alright, guys, that's all I got. So thank you so much for watching. I'm Shawnthebro, and I'll see you in the next one. Goodbye, guys.